Good morning, guys. Today we are going to solve one more problem, that is on penalty method. Now, already I solved one problem on penalty method. This is the next problem, that is problem number 5 with initial displacement concept. Now, take a bar. A problem first. You read the problem. A bar is loaded as shown in figure. An axial load of P equals to 60 kN is applied at the midpoint. Using penalty method of handling boundary conditions are determined. First one is nodal displacement, second one the reaction support, stress in each element. And these three parameters already we have discussed how to determine in the previous problem. Same thing, only determining but a different concept. Okay. Now that is different concept means the problem itself is given as a different one. Now if you observe, this is the problem given. Okay, area is 250 mm square, Young's modulus is given, length is given, load is applied at the midpoint is given, x is given. Now for this problem, first you should see that. See, if you neglect, I have done the node numbering, but if you not done the node numbering, you should consider this as an two elements. Why? Because the load is acting at the center. If load is acting at the ends, we know that it is a constant cross section. We can use single element and we can solve it. But when the load is acting at the center, you cannot formulate a force vector. For example, if you take only two nodes will be there, load is acting at the center means how you can represent your load in a force vector, because you can represent load only at the nodal points. So if you want to represent your load acting in a member in the nodal format only, you can represent it. That because of that, you should locate a node at this particular point also. Now we have located three nodes. Just observe 1, 2, 3 with respect to the direction of x. Load is, we know that what is the load applied. Now he has given a 0.12. I will take this as A3. A3 is equals to 0.12 millimeter. This is your initial displacement. That is at node 3. Why A3? Because it is nearer to node 3. That means it is up to node 3. Because of that, we have taken A3. Similarly, if anything is given at node 1, I can take that as a A1. If you are given at 2, it is a A2. Because of this, you can see where A3 I have taken. Now, what is the first step? You know that FEA model for continuum. First, this is your given continuum. Convert it to FEA model. We know that how to represent. Represent like a line element. 3 nodes, 1, 2 and 3. We know displacement, what we can consider Q1, Q2 and Q3. Then length is given L1 and L2. Okay, then forces F1, F2, F3. Then here area. See, area is a constant cross section. I am taking area for both A1 and A2 will be equal to 250 because I am taking it as two elements. E is common for both elements, 2 into 10 to the power 5, because there is no any here different element. Only it is made up of only one material, that is E will be equal to 200 GPa because I am taking L1 and L2 will be equal to 150 mm. Length is 150 mm. Over length is given because both elements having the same length. Now what is the first step? Second step will be formulate your element of stiffness matrix. We know what is the element of stiffness matrix for a bar. AE by LE 1 minus 1 minus 1 1. Now how to calculate your element of stiffness matrix? Substitute. What is the area? 250 mm square, that is 250 into 2 into 10 to the power 5 divided by 150. If you solve it, you are going to get 3.33. 10 to the power 5, keep it common. If you calculate 3.33, now 3.33 minus 3.33 minus 3.33, 3.33, 1 2, 1 2. Now repeat the same thing for second element. Now calculate element of stiffness matrix for your second element. Okay, that is element of stiffness matrix for your second element. That is K2 is equals to, now I am repeating, K2 is equals to AE by LE 1 minus 1 minus 1 1. What is the area of second element? 250 only. Area is not changing. 250 into Young's modulus is 2 into 10 to the power 5. Okay, length is 150. Now 1 minus 1 minus 1 1. Now if you see this, what is the value you are going to get? Same 10 to the power 5, because same values are there. 3.33 minus 3.33 minus 3.33 plus 3.33. Now what are the nodes? Nodes will be 2, 3, 2, 3. This is your second element. Okay, after doing your second element, now what is the next step you should do is, now you calculate two element of stiffness matrix. Next we want to calculate what is the global stiffness matrix K. How to calculate global stiffness matrix? K will be equal to K1 plus K2. That is stiffness matrix of element number 1 and stiffness matrix of element number 2. Now if you observe, what is a K1? K1 having a 2 rows, correct? 1, 2. The second one also having a 2 rows and 2 columns. But if you observe node numbers, 1, 2, 3 and 1, 2, 3 is there. And also if you see your continuum is consisting of 3 nodes. At each node you are getting one displacement. Because of this, your order of the matrix for the continuum. See, global stiffness matrix means you are formulating a stiffness matrix for continuum. FEA model means you are calculating a stiffness matrix for an element. Now calculate stiffness matrix. What is the order of the stiffness matrix? It should be 3 cross 3. 1, 2, 3, 1, 2, 3. Now you can know that how to calculate this. 3.33 minus 3.33. It already explained the previous because I'm directly writing minus 3.33. Now 3.33 plus 3.33, what is this? 6.66 minus 3.33. This is 0 minus 3.33. This is 3.33. Now this is your global stiffness matrix. After global stiffness matrix, what is the next step you want to do it? You want to do your global force vector and displacement vector. First we will take displacement vector. Displacement vector. What is displacement vector representation? Q. How many Q values you are going to determine? 3. That is Q1, Q2, Q3, because 3 nodes will be there. Then what is the next one? Force vector. What is force vector? You know how to calculate force vector. Capital F. Capital F will be equal to TE, FE plus PE. But in this problem presently TE is not given, FE is not given, only PE is given. That is, what is the point load acting at node 1? That is 0. Point load acting at node 2 is 60,000 because it is with respect to the direction of X. And then 3 it will be 0. This is what your global force vector. Global force vector. Now you got F, you got Q, you got K. Now write equilibrium equation for continuum. What is the equilibrium equation for continuum? K into Q is equals to F. K into Q is equals to F. What is K into Q is equals to F? 10 power 5, 3.33 minus 3.33, 0 minus 3.33, 6.66 minus 3.33, then 0 minus 3.33, 3.33. This is your K. What is Q? Q is equals to Q1, Q2 and Q3. What is F? F is equals to 0, 60,000 and 0. This is your formulation of your equilibrium equation for continuum. Then after formulating equilibrium equation for continuum, next step is using your penalty method. What is your penalty method here? Because first concept is same. Penalty method means you should calculate your penalty value. What is the penalty value means? C. How to calculate C? C is equals to maximum of Kij. Maximum of Kij into 10 power 4. I think what is maximum of Kij means? What is that? Take maximum value in the stiffness matrix. What is the maximum value in the stiffness matrix? If you observe, so if you observe your maximum value in stiffness matrix, 6.66 is the maximum value. Now take what is the maximum value? 6.66 into 10 power 5 into 10 power 4. That will be equal to 6.66 into 10 power 9. 6.66 into 10 power 9. C will be equal to 6.66 into 10 power 9. Now what you want to do it? Add this value to the fixed nodes. Add this value to the fixed nodes. Add the value of C to the fixed node. Fixed node. What are the fixed nodes? 1 and 3. 1 and 3. 1 and 3 means where you should add it? You should add A11 and A33. Now repeat this step. What is K now? 10 power 5 common. Now this is minus 3.33. What is the value you should add? Sorry, plus 3.33. What is the value you should add? 6.66 into 10 power 9 is there already. 10 power 5 is outside. 10 power 4 minus 3.33 0. Then minus 3.33. This is 0. Here what is the value you are going to get? 6.66. What is the value here? Minus 3.33. Now minus 3.33. Here also what is the value you are going to get? 3.33 plus 6.66 into 10 power 4. This is over. Now come to here. Q1, Q2, Q3 is equals to. Now come to here. Just observe the force. Force at node 1, F1 is equals to 0. Correct? F2 is equals to 60,000. Just I am writing with the concept. Okay, 60,000. When you come to node 3, is it node 3 is fixed? Just observe your problem. Is it node 3 is your fixed? No. If you observe the problem, node 3 is not fixed. Node 3 will become fixed when it will travel a distance of 0.12. It will travel a distance of 0.12. That means if it has to travel a distance of 0.12, you should use here, in place of F3, you should use a concept called F3 plus CA3. If F3 plus CA3. But F3, what is the force acting at node 3? There is no point load, that is 0. Plus what is CA3? Penalty value. What is penalty value? 6.66 into 10 power 9 into what is A3? A3 will be equal to 0.12. See, this will not come in your previous problem because previous problem initially itself it is fixed. But in this problem, initial displacement is given. See, initial displacement is given, a gap is given, means when it will fill the gap. See, if you applied a certain penalty value, it will take to that position. But when it reach to 0.12, it will behave like a fixed. Because of that condition, you should make here F3 plus CA3. F3 means any point load is acting at node 3? No, point load is 0. Now this is this one. Now that means what you want to write here, your force is around, your force will be 0, 60,000 and 6.66 into 10 power 9 into 0.12. This is your force value. Now this side, write your same K into Q. What is K into Q? Now obtain K into Q, write it. What is obtain K into Q? 6.66 into 10 power 4. 6.66 into 10 power 4 plus 3.33. What is the answer you're going to get? 66 point, that is 6.6603 into 10 power 4 minus 3.33 0 minus 3.33 6.66 minus 3.33 0 minus 3.33. This is once again same 6.6603 into 10 power 4 into Q1, Q2 and Q3. Now using your calculator, there are three values, correct? Three unknowns will be there, Q1, Q2, Q3. How to use it? Formulate three equations. What is that equation? 6.66 into 03 into 10 power 4 into Q1 minus 3.33 into Q2 is equals to 0, because 0 into Q3 is 0. Similarly, 10 power 5 minus 3.33 into Q1 plus 6.66 into Q2 minus 3.33 into Q3 is equals to 60,000 is the one equation. Take the equation number 1, equation number 2, and third equation 10 power 5 0 into Q1 minus 3.33 into Q2 plus 6.6603 into 10 power 4 into Q3 is equals to, what is the value you are going to get? 6.66 into 10 power 9 into 0.12. Just check it. You are going to get 799.2 into 10 power 6. That is equation number 3. Now using your calculator, three unknowns, calculate what is your displacement. If you calculate, you are going to get Q1 is equals to 7.5 into 10 power minus 6. Okay, you are going to get Q2 is equals to 0.1015009 millimeter, and Q3 is, just observe Q3, you are going to get around 0.1200015. That means almost same value you are going to get it. Okay, same value what you are taken as a A3, you get it. Okay, this is what how to determine your displacement. Now after calculating your displacement, you know they repeat the same procedure for calculating your stresses and strain. Now how to calculate stresses and strain? Take your concept, say sigma is equals to, what is sigma? Sorry, epsilon is equals to, epsilon 1 is equals to, what is epsilon 1? Epsilon 1 is equals to B into Q. What is B into Q? 1 by LE minus 1 into Q1 Q2. What is we are calculating? We are calculating for element number 1. What is the length of element number 1? 150 mm minus 1 plus 1. What is Q1? Q1 obtained. Just observe what is Q1 obtained. Q1 is 7.5. 7.5 into 10 power minus 6, and Q2 obtained is 0.1509. If you multiply this, you are going to get epsilon 1 will be this. Now how to get your stress value? Very simple. Sigma 1 is equals to E into epsilon 1. What is E? 2 into 10 power 5 into epsilon 1 is what? How much? 1.0055 into 10 power minus 3. You are going to get this value. That is 200.11. How to get your epsilon 2? Repeat same thing. BQ, that is element number 2, 1 by LE2 minus 1, 1, Q2, Q3. What is 1 by LE1? That is 1 by 150 into minus 1 plus 1. What is Q2, Q3? Q2 is 0.1509, 0.15009, not 09, 009. Similarly, here 0.120005. If you solve it, you are going to get this value. Okay, then sigma 2 will be equal to, very simple, EBQ. What is E? 2 into 10 power 5 into epsilon 2 minus 2.0059 and 10 power minus 4. You are going to get a value of 40.118. Now after this, how to calculate your reaction? Reaction will be, the formula will be same, R1, because what is the reaction force? You can get at node 1 and node 2. You are going to get at node 1 and node 3. You are going to get node 1 and node 3 because two nodes are fixed. R1 equals to minus C into Q1 minus A1, but still in this problem A1 is what? 0, because there is no initial displacement. Minus C1, what is the minus C1 value? Minus of 6.66 into 10 power 9. What is Q1? That is 7.5 into 10 power minus 6, and A1 is equals to 0. We are going to get 49,950, or we can write 49.595 kilonewton. Similarly, how to calculate R3? R3 is equals to minus C into Q3 minus A3. Q3 minus A3. Now you should write Q3 will be equal to 0.120015. I think 0.120015. You got it. 0.120015. You got it. Sorry, Q3, and A3 will be equal to 0.12. If you calculate this, you are going to get 9.99 kilonewton. This is what the method of solving in a problem. Another, that is when initial displacement is given. When initial displacement is given, if these kind of problems are given, you should use, this is the technique. Okay, this is what the solution for the given problem. Solution for the given problem. Now this is the problem. Thank you.